So hey guys, today I'll be talking about data structure known as tree. So what is a tree? Let's go first understand what is a tree. A tree is basically a nonlinear data structure. So what does this nonlinear mean? So you have seen that there are some data structure like linked list, array list, and other things like stack queue. All those are linear data structure. What does that mean is this stores like this data is stored in linked list is stored like this. So it's basically a linear data structure. Whenever you want to find something 10, 15, 19, 60, so let's say you want to find 19, so you have to traverse through the whole linked list to get to 19. So you have to traverse linearly to get to this 19. So basically this kind of data structures are known as a linear data structure. But what in case of tree, it's a like non-linear data structure. So what is a tree? Like a tree has a node, and a node can have as many childs as you want. It can have one, it can two, three, four, five. So basically this is a tree, and it and those childs can have many more trees. So basically this is a tree. Listen to the things I am telling here. This is a tree. I am not mentioning any number or something. This is just a tree. So this is the n-way tree or m-way tree, or sometimes I have read like k array, m array, n array. All these are same things. So this is a tree, and data is stored like in a hierarchical manner, like 10, 20, 30, 40. It doesn't matter. It can be stored in any manner. So now, what is a binary tree? So a binary tree is a tree. What is it? So a binary tree is a tree which can have, in tree in which a node can have at most two children. So what does this mean? So the things I drew previously, these circle things are nodes. Nodes stores the data. So this node can have only two children. This one children, two children for binary tree. And previously, which I discussed, the other tree, it can have as many child as it wants. There is no limitation. But in case of binary tree, this condition is must. A node can have at most only two children. So now you can ask me, what is a node? So you can if you know Java, you can think of node as a class, like class node. And a node can have a reference to next two nodes, like reference to the left node and right node. So it will be another node, node left, node right, and the data that the node holds itself, like it can be a string, it can be data, it can be int, it can be anything. So for now I'm taking it as a number. Okay, so this you can think of node as this, like abstract data type is like the class. Node represents the class. So now, so I guess you got what is the binary tree. Now what is a binary search tree? So basically binary search tree, uh binary search tree is a special type of binary tree where the data in the right node, right child node, is greater than the parent node, and data in the left node of the parent node, and the data in the left node of the parent node is always smaller than the parent node, than the data in the parent node. So what does this actually mean? I know it's a big thing I wrote, but it's not like difficult to understand. Let's say you have this binary tree and you have entered 10. So anything greater than 10, if you want to insert into the binary search tree, it goes into the right side of this node 20. Anything less than 10, you can insert it in the left part of the parent, like 5. So I will insert something and I will show you 5, 10, 15. Sorry, let's take another thing. 50, 25, 17, 80, 90, 110. I will insert this into binary search tree so it will be clear for you. Let's say first came 50, so I will insert 50 into the node. This is the parent root node. Then came 25. 25 is less than 50, so it will go into the left part of the binary search tree. Then came 17. 17 is less than 50, and 17 is also less than 25, so it will go to the left part of this 25 because it is less than 50. So I will come here and I will check it is, if 17 is greater than or less than 25, it is less than 25, so it will go to the left part of 25. Then comes 80. 80, while inserting it, I come to this root node and ask, is 80 greater than 50? Yes. So this 50 will guide me to the right part of the right part, and I see no one is there, so I will no node is there, so I will insert 80. Next thing is game 90. So 90 will come and asks the root node that if 90 is greater than 50 or less than 50. 90 is greater than 50, so 50 will tell me to go here. And I will come to the 80 and ask if 90 is greater than 80 or less than 80. So 90 is greater than 80, so 80 will tell me to go in right part. So I will come here and see no one is there, so I will put 90. Then I will then 110 will come. 110, I will come to 50 and ask 110 will 50 is 110 is greater than 50? Yes. So 50 will tell me to go in this direction. I will come to 80 and ask 110 is greater than 80 or less than 80? It is greater than 80, so 80 will tell me to go here. And I will come to 90 and ask if 110 is greater than 90 or less than 90, and 110 greater than 90, so 90 will tell me to go in the right side. So no one is here, I will put 110. So this is basically how a binary search tree works. So what's the benefit of using a binary search tree over a tree? So you can see we have a clear defined like rule that anything like the number greater than the root node will go to this part, and less than the root node will go to the left part. So this makes things easier for searching, because and also we can search the tree in like log n time. So how, the question is how. So in tree we have a notion like height of the tree. This is the level 0, it is level 2, this is level 3, this is level 4. So what's the height of this tree? We can say the height of this tree is 4. Sorry, I did a mistake. This is 1, level 1, level 2, level 3. So in everything and other things, I want to mention some things like this is a leaf node, this is also a leaf node, because it's there is no node, like no left or right node, so it doesn't have any like children node, so this is called a leaf node. and these are called internal nodes. Why? Because these are not these are internal in the data structure like tree. These are all internal nodes.